consider z as a standard normal random variable, and identify the x value for which the probability of z being less than or equal to x is 0.60. Now this time we are not being asked the probability of z being less than or equal to or greater than or equal to something. This time we are given the answer, the probability, and the question is asking for which value of x the cumulative probability is going to be equal to 0.60. So we need to check the normal table from an inverse perspective. Now let's check. This time I am going to look at the x values, but I need to find the probability as 0.6. So this time probability is going to be equal to 0.6, the cumulative probability. The area on the left-hand side of x must be equal to 0.6, and I need to find the x value. So where is 0.6? It is somewhere between these two values, right? 0.5987 and 0.6026. So this means the critical x value, the threshold x value that we are looking for should be somewhere between 0.25 and 0.26. So we can see that in the presentation file as well. So I am looking for the probability to be equal to 0.60, but I cannot see that probability exactly here. So x value should be somewhere between 0.25 and 0.26. So what I observe is this. For x value, which is 0.25, the cumulative probability is 0.5987. And for x value, which is 0.26, the cumulative probability is 0.6026. For which x value the cumulative probability will be 0.60, again, I am going to apply linear approximation, but this time from an inverse perspective. Now, look at the distances. For these two values, the distances to 0.60. The distance of 0.5987 to 0.60 is 13 units, and the distance of 0.6026 to 0.6 is 26 units. So I am going to multiply this value, which is 0.25, with 26, and I'm going to multiply this value with 13, with the opposite distances, and divide the summation to 39, which is going to give me a weighted average of 0.25 and 0.26. So my critical threshold value is 0.2533. Now, you can see this picture to understand this better. So at 0.25, the CDF is equal to 0.5987. At 0.26, the CDF is equal to 0.6026. And I am looking for the x value for which the CDF is equal to 0.6. Now, in order to do that, I need to apply linear approximation in the inverse perspective. Now, you see the proportions of these distances is 26 to 13 units. Therefore, the proportions should be here as well, 13 and 26 units. And this helped me to calculate that the inverse CDF at 0.6 will be 1/3 close to 0.25 and 2/3 close to 0.26, which is 0.2533. Now, another question is this. Again, I am going to identify an x value for which the standard normal random variable is less than or equal to x is going to be equal to 0.10. So let me draw you this picture here for part B. So this is the probability density function of the standard normal distribution. And there is a certain x value here, which I do not know yet. And the area on the left-hand side of this x value is 0.10. And the right-hand side will be 0.19. So that is being asked here. So the probability of z being less than or equal to x must be equal to 0.10. And that x is being asked. Now remember, if you look at my CDF table, I can get the probabilities for positive x values only. According to this figure, if my x is in the negative region, I will not be able to find it. So I am going to use the symmetricity of the standard normal probability density function. And I will say that let's just check the x value for which the area on the right hand side is 0.10 and the area on the left hand side is 0.90. If you find this x value, again you are going to use the symmetricity and you will call that value is the negative version of that x value. This means if I am going to identify the x value for which the cumulative probability is 0.10, I am going to look for the z value for which the cumulative probability is 0.90, and I am going to take the negative of it. If I am interested in the inverse CDF of the standard normal random variable at 10, that is going to be equal to the negative of the inverse CDF at 1 minus 0.10. So the inverse CDF at 0.90 will be 1.2817, and the negative of it is minus 1.2817. So I need to find 1.2817. So what does that mean? I need to identify the critical x value for which the cumulative distribution function is equal to 0.90, which is the area on the left-hand side. So let's look for 0.90 now. It is somewhere between these 2 points, right? So we have 0.8997 and 9015. Then the critical value is somewhere between 1.28 and 1.29, right? Now, again, by using the linear approximation idea, I can calculate that value is 1.2817. For the third part of this question, part C, we are going to identify an x value for which the standard normal random variable to be between minus x and plus x is going to have a probability of 0.95. So we are looking for a positive x value, and the probability that the standard normal random variable to be between the negative and the positive version of that value should be exactly equal to 0.95. So this is the thing that I am looking for. So this is the probability density function of the standard normal distribution. And I am looking for an x value such that the area between the negative and the positive of this x value will be exactly 0.95. This means both the right tail and the left tail will have remaining areas of 0.025, right? Because the remaining area is 0.05 and half of them will be on the right hand side and the half of them will be on the left hand side. So what is this x value? What is the result? How do I find this 1.96? So this is the explanation. So my objective is to determine this probability, right? What is this probability? The CDF at x minus the CDF at minus x, right? So the CDF of standard normal distribution at x, which is the area on the left-hand side of x, minus the CDF of the standard normal distribution at minus x. So this is what? This difference is basically the total area on the left-hand side of 1.96 minus the total area on the left-hand side of minus 1.96. Now, this is going to be exactly equal to 0.95, my friends. Now, if you check this out, 5 minus x is equal to 1 minus 5x. Remember now, the area on the left-hand side of a negative value is equal as the area on the right-hand side of the positive counterpart of it. Why? Because the PDF is symmetric around 0. Now, according to that, we can replace this 5 minus x with 1 minus 5x, and that equation is going to be equal to 0.95 according to the question. Now, from here, you can easily determine that 5x must be equal to 0.975. Or you can understand that from the picture. So the total area on the left-hand side of x must be equal to 0.95 plus that 0.025 area. So it should be equal to 0.975 on the left-hand side of 1.96. So this means what? I am going to look for an x value for which the area on the left-hand side is 0.975, or in other words, I am going to look for the inverse CDF of 0.975. Now let's check our table. In my table, I have 0.975 here exactly, which is at 1.96. So the result is 1.96, my friends.